Just to make sure we're heading in the right direction here. Finding the perimeter of this. What we have here are 5 half circles. All of them are half circles. But there are several different diameters that we're dealing with. So let's start out with for perimeter, we're just looking at the distance. That rectangle that's dotted there is just a guide to show you that it's a rectangular shape. Those are not real lines. So let's start out with these two on the bottom here. This one and this one. First of all, those are 2 half circles. I can put them together to make one whole circle. The diameter across there is this distance, must be half of the 20. So that is a full circle with a diameter of 10 inches. So remember, when we're dealing with perimeter on a circle, it's called a circumference. That's just pi times diameter. So that'll be 3.14 times 10, or 31.4 inches for that one. Next, we'll have these 2 half circles. They are both half circles of the same size. They have a diameter of 12. I can put those 2 half circles together to make a single circle with that diameter of 12 inches. So the circumference around that is pi times diameter again. 3.14 times 12, which is what? 37.68, I believe, inches. So, well, because the 20 here goes all the way across, and the diameter of this is only half that. Because that circle just cuts that side in half. 12 goes all the way across, but that's also all the way across the circle. So it's because there are 2 circles that line up on the 20 there, and only 1 circle that lines up on the 12. So the 12 didn't get cut in half. So then, finally we have this big one, which is truly a half circle. We treat it as though it were a full circle, so we find its full circumference. That full circumference is going to be pi, so 3.14, times 20, because that's its diameter. But then we are going to divide it by 2. Why did we divide it by 2? Because we only have half the circle. So 3.14 times 20 divided by 2 is 31.4 inches. So we add those up. That's 100.48 inches is our perimeter.
When you get a problem like this, you have to break it.
Break it into pieces you can find. Yeah, you have to break it down into pieces and add them all up. Remember, perimeter is found by adding up all of the sides or all the pieces of the sides. This here, adding those 3. For area now, the area of this one's going to be slightly more complex. So we're going to start up. Remember, we talked about sometimes when you have complicated shapes, you add up pieces. Sometimes you subtract pieces. Here we're going to have to do both. We are going to start with this rectangle here. The area of that rectangle I actually put A for area and then draw the rectangle there, is 20 inches long by 12 inches wide, which is 240 inches squared. So that gives you the area that I outlined in yellow here. But from that, I have to take out these two half circles, right? Because they're cut out of it. So I'm going to subtract those. Those two half circles came together to make this one whole circle right here with a diameter of 10. But for area, we don't need diameter. We need radius. And its radius will be 5. So we're going to subtract the area of the circle with radius 5. So that's going to be pi, or 3.14 times 5 squared, which is 78.5 inches squared that will be subtracted. So I'm going to go ahead and do that subtraction quick. I subtract that, I get 161.5 inches squared. Next, I need to add in these pieces. Those have to be added in because they're extra outside of the rectangle. See, I had that rectangle that was highlighted there. These pieces had to be subtracted because they were inside of it and they're cut out. These pieces are outside of that rectangle, so they have to be added on. So again, that is just a circle with a radius of 12, or a diameter of 12. So we need to know from that it has a radius of what? 6. So the area of that circle, we're going to add that one, is 3.14 times 6 squared. Oops, try that again. 113.04. So we add those up. We are at 274.54 square inches so far. We're not done yet. There's one more piece we have to add on. What piece is that? That half circle up there. Again, we're going to treat that as though it's a full circle and then just divide it by 2 to get half of it. That has to be added on because it's outside of that rectangle. It has a diameter of 20, so it has a radius of 10. So for that area, we're going to add the area of the half circle. That's pi 3.14 times 10 squared, but then what else do we have to do to it? It's a half circle, so it's divided by 2. So that ends up being 157. The 6 squared was a half circle here and a half circle here, so it makes one full circle. This is just one half circle. There isn't a second half to combine with it. So we add that on. 431.54 inches squared. That's the answer. That's the area. See how easy that is? Sorry. We also talked about areas, or volumes, I should say. Volumes were that next step. Once we had an area, we could multiply it to find a volume. For example, I'm going to do a little bit of a weird shape here. So this is the base of my figure. So what this base is down here, I'm going to put that in green so I can identify it. How do I know it's the base? Well, one, it's on bottom, but the base is not always on bottom. The reason I know that's the base is because that is the side of this figure that I can actually take and I can slide through it and make it. Think of like sliding a cookie cutter through cookie dough. You slide it through the cookie dough and it cuts out the shape. That's the same thing here. Because if the outline of this base were a cookie cutter, I'd slide that down through the cookie dough and it would cut out this shape. Does that make sense? You can slide it from the top too. The top here would be the same thing. Most of these figures have two bases, one on one side, one on the opposite side. So yeah, you can slide it from the top or the bottom, either one. So that's my base. And the volume is the area of that base times a distance that's usually referred to as a height. So we'll call it h. So here we must first find the area of the base. So I got to give you some measurements down here. Let's tell you that this here is 8 inches. This over here we're going to call 10 inches. And this height we're going to call 10 inches as well. So we're looking at the base down here. We're going to divide that up into two shapes. This is a rectangle that is 8 inches here by 10 inches here. That's piece one. So 8 inches by 10 inches. That's an area of 80 square inches. But we still have this piece on the base yet. What shape is that? Half a circle. So I'm going to treat it like it's a full circle. So that's going to be pi. I'm just going to go 3.14 times. What's its radius? Well, what's this distance across here? 8. That's the diameter because it goes all the way across the circle. So the radius would have to be 4. So pi times 4 squared. But it's only half a circle, so we have to divide by 2. Comes up 25.12 square inches. We add those together, we get 105.12 square inches. That's the area of our base, right there. We use that then to find our volume. Take the area of our base, 105.102 or 105.12 square inches, times our height of 10 inches. So that becomes 1,051.2 inches cubed. There's my volume right there. So that's my solution. That is the volume. Next, we want to talk about surface area. Surface area is going to be split into two parts. Part 1 is area of the base or bases. Well, if we're finding the volume, we need the area of the base too, don't we? Up here, we found the area of the base. So if we're finding both volume and surface area, we need the area of the base for either one of them, for both of them. So if we're doing both volume and surface area, that saves us some work because we find that area of the base for one, we've got it then for the other one. The second part is something called lateral surface area. Lateral surface area is going to be abbreviated LA, lateral area. Lateral surface area is the area of the sides that connect the bases. So up here, we had that base on bottom, that's when we found the area of. And as Marissa pointed out, the top could be a base too. The top is the same shape. This actually does have two bases, one on bottom, one on top. And that's usually the case. In many of our figures, we have identical sides on opposite sides. Those are the bases. The lateral area is the area of these surfaces that wrap around. Did a really poor job of coloring that in. Let me try that again. So it's like this rectangle here, and then these surfaces that wrap around here. Does that make sense? So we're going to look at a simpler shape to look at lateral area. We're going to do just a simple box here for a second. So there's the base of our box. Eight inches by 14 inches, we're going to call it. We'll say it's 10 inches tall. Now, we had mentioned yesterday that in a box, pretty much any side of the box can be the base. Because I could actually take this end here, I could actually slide that through the object, couldn't I? I could slide that through and it should match up on the other side. Any surface of this can be a base. So on a box, we usually just choose the bottom to be the base because that's, visually, that's the way our mind likes to think of it anyway. So the area, we're finding surface area, of course. So when we're finding surface area, the first thing we want to find is the area of the base or bases. So for this one, is there just one base? Say no. There's two. There's one on bottom and there's one on top. There's two bases. Well, the area of the base is just 14 inches by 8 inches, which multiplies to be 112 inches squared. Because we're adding up all of the surfaces. One way we could have done this is we could find all the rectangles, add them together, but we're looking for a shorter way of doing it. That's where we're finding that lateral area. And also, not every shape is going to have rectangles for those lateral sides. Sort of. For us, we're either going to have shapes that have two bases and both are the same, or we will run into shapes that only have one base. We'll get to those in a little bit. So you notice I wrote down the 112 twice. That's 112 for the bottom and 112 for the top. Both of the bases are now included. So all that is missing here is this front side that's a rectangle. That's a rectangle that's 14 inches here, 10 inches high, right? 14 inches by 10 inches. I'm missing this side here. That's a rectangle. That's 8 inches here by 10 inches high. I'm missing this back side. That's a rectangle. That's how big here? 14, and this is still 10, right? Then I'm missing this end over here. That's 8 inches by 10 inches. Now I drew them out this way on purpose. Basically what I'm doing here is I am taking that lateral area that's like folded up here, and I'm slicing down one of the corners, I'm rolling it out, and it makes one big rectangle. So I am literally, what I'm doing is I'm slicing this down the corner here, and I'm folding these rectangles out to make this one big rectangle. And that's why we defined lateral area. This is the lateral surfaces right here. And on most of our shapes, no matter how weird they look, the lateral area can be folded out into a big rectangle. And the height of this rectangle is just the height of the figure. That 10 inches is that 10 inches. The length of this rectangle will be found by adding those dimensions together. But where did those dimensions come from? That's just the perimeter of our base. Does that make sense?
So, if question asks, what's the lateral surface?
Well, it won't ask for the lateral surfaces, but it might ask for the lateral surface area. So the lateral surface area, LA, is going to be equal to the perimeter of the base times the height. So the perimeter of the base here is found by adding those up. 14 plus 8 is 22, plus 14 plus 8 is 44 inches. So our lateral surface area here is 44 inches is the perimeter of our base, times our height of 10 inches is 440 inches squared. So our total surface area is that number added to the area of the bases. So we add those all up, we get 664 inches squared. That is my surface area, my total surface area for that figure. Why did I go through such painstaking effort to define this lateral area when I could have just said, hey, here's a rectangle that's 10 by 14, a 10 by 8, a 10 by 14, a 10 by 8, and just added up all the rectangles? Because not every shape has nice, pretty little rectangles for sides. For example, I could have a shape like this. A cylinder. This cylinder, we're going to give it a diameter down here of 8 inches and a height of 10 inches. First of all, let's find volume. And then we're going to find surface area. This problem right here is one of the reasons why I define volume and surface area the way I do in this class. Volume, remember, is the area of a base times the height, right? The base in this shape is that circle, because that's what can be slid through the whole object to cut, the cookie cutter, right? So the area of the base here is pi 3.14 times radius, there we go, which will be 4 inches. So 4 squared, which will give us 50.24 inches squared. First of all, does anybody have any questions where I got that 50.24? Okay. So then our volume is area of the base times the height. So the area of our base is the 50.24 inches squared times our height, which is 10 inches. That's 502.4 inches squared times inches is inches cubed. That's the volume right there. For surface area, I need to know the area of the base. Well, I already know that. Right up here. 50.24 square inches. Do I need to write it down once or twice? Twice, because there's another one on top. It's just the same, right? So 50.24 square inches. Then I need to find the lateral area. To find the lateral area, I need to know the height, which I know is 10. But I need to know what other piece of information? The perimeter of the base. The base of this is a circle. So its perimeter is a circumference. So it's going to be pi, or 3.14, times diameter, the 8. 25.12 inches is the perimeter of my base. So then my lateral surface area is the perimeter of that base times the height. So we're going to do the 25.12 inches times that height of 10 inches is going to give us 251.2 inches squared. I have to add those three up to get my total surface area. It might ask you for it would never ask you for just the area of the bases, but it might ask you for just lateral area. Lateral area or lateral surface area. You have to write everything. Yes. Occasionally, we run into something. Looks like this. Of course, you're looking at this, and it is a pyramid. We're only going to deal with pyramids that are the same on all sides, so they have square bases. Let's explore the volume of this. If I had a box, if I cut that box in half, would I get a pyramid? Well, if I cut it here and here, that's basically cutting it in half, right? That's not a pyramid, is it? That's a wedge. So the volume of that pyramid is less than half of the box that contains it. If I wanted to turn that into a pyramid, I'd have to cut it here and here. Now it's a pyramid. Now, I didn't take off half of what was there because I took off the top part that was the thin, pointy part. And I left all of the big, wide base. So I didn't take off another half of it. Well, to get the exact amount that's still there, we'd have to go through calculus. And I don't want to do that. So this is one of the few times we know it's between 1/4 and 1/2 of the whole box. It actually comes out to the volume for a pyramid. Actually, anything that has one base and comes to a point, the volume is the area of the base times the height, just like we did before, divided by 3. It's 1/3 of the box that would contain it. One of the ways I remember that is this. When we're doing areas, I have a rectangle. If I know the area of the rectangle, how do I find the area of the triangle? Divide by 2, right? How many dimensions is a rectangle? That's 2 dimensions, right? Length and width. Well, a box is 3 dimensions. So when we trim that down into a cone, it's 3 dimensions divided by 3. That's how I remember it. It's not necessarily the relationship as to why we divide by 3, but that's how I remember that when we're doing volumes, it's cut out of the full box, but it's 3-dimensional, so we divide by 3. So let's find the volume of this pyramid. First step to finding volume is always area of the base. What's the area of the base of this? Well, it's just a square that's 10 feet by 10 feet, which is 100 square feet. That's not so bad, right? So then the volume, area of the base times the height divided by 3. So the area of the base is 100 feet squared times my height of 12 feet divided by 3. That comes out to 400 square feet times feet is feet cubed, or cubic feet. That's my volume. Not bad, right? Let's look at surface area. First of all, when I'm doing the surface area of this, I need the area of the base. Notice I didn't say base or bases, I just said base because only one. The only base here is on bottom. The changes come in the lateral surface area. The lateral area still is going to involve the perimeter of the base. But it's not going to be times the height anymore. On these shapes up here, the sides went straight up and down. So the height of the object was the height of that rectangle that makes the base, right? Here, however, the sides do not go up and down. They go at a slant. So the height of this, the length going up that side is not the height of the figure. It's going to be more than 12 because it goes up at a slant. Well, how do we find how long that slant is? Well, I draw in this triangle here. That's a right angle. This side here is that height of 12. What's this side here? Well, this should fall right in the center of that base. So this side should be half of the side of the base. So it would be 5 feet. So what I have there is a right triangle. It's 12 feet here, 5 feet here. How do I find this side? A squared plus B squared equals C squared. So 12 squared plus 5 squared equals that side. I'm going to actually call it side S for slant. Ends up being 13 feet. Shortcut, you just do second square root, 12 squared plus 5 squared. Gives you 13. So it is the slant. So it is the perimeter of the base times the slant. And now, since those shapes are not rectangles anymore, they're triangles, we divide by 2. The perimeter of the base here is 10 plus 10 plus 10 plus 10, or 40 feet. Right? So the lateral area here is the perimeter of the base, the 40 feet. Just to clarify, this is a square that's 10, 10, 10, 10. So I just added up the sides, is all I did. So 40 feet times that slant of 13 feet divided by 2, because those are triangles now. I get 260 square feet per lateral area. So I add the area of the base to the lateral area. My surface area is 360 square feet. What do you think? The brain's starting to hurt yet? A little bit? Yeah. I know this week is a pretty intense week with this stuff. This is a cone. Cone follows the exact, just like the cylinder, because of the way I defined the formulas, when I did this cylinder up here, it worked exactly like any other shape. Well, the cone, because of the way I defined the formulas, the cone is going to act exactly like our pyramid here. So to find volume, what's the first thing I always need to find? Area of the base. So that's going to be pi 3.14 times the radius will be 8 squared. So 8 squared is going to be pi times 8 squared is going to give us 200.96 inches squared. It's the area of that base. It's the area of that circle. So then our volume for the area of that base, 200.96 inches squared, times the height of 15 inches. What do we have to remember to do to it? Divide by 3. So 1004.8 inches cubed, correct? That's volume. That's not hard. Surface area. Well, the first thing we need to find for surface area is the area of the base. We know that one already. 200.96 square inches. Found that up here. There's only one of them, so I only need to put it in there once. For lateral area, I need to know two things. One, I need to know the perimeter of the base. Since this is a circle, the perimeter of the base is going to be a circumference. It's going to be pi 3.14 times the diameter of 16 inches, otherwise known as 50.24 inches. That is the perimeter of the base. I also need to know the slant. The slant is going to be found right here. I draw this down. That's the height of 15 inches. This is going to be the radius of 8 inches. I have to find the hypotenuse is going to be the slant. So it's going to be 8 squared plus 15 squared equals that slant squared. I'm going to trust at this point you guys can do that a squared plus b squared equals c squared and calculate it out. We're short of time, so I just don't have time to do it right now. So we got 17 inches is that slant. The square root of 8 squared plus 15 squared, if you want to do a thing with that. 17 inches. So our lateral area is the perimeter of the base, 50.24 inches, times the slant, 17 inches, and because those form triangles, basically, it's divided by 2. Giving us 427.04 inches squared. Not by the height? Because on the other objects, because the sides went straight up and down, the height of the side, or the width of the side, was the same as the height of the figure. This goes up at an angle. So it's 15 inches from top to bottom, but you go up the slope, it's longer. It's 17 inches. So when you do the area, you got to account for that. The last thing we're going to talk about today we're talking about a sphere. For the volume and the surface area of a sphere, I could show you where these formulas come from, but it would involve calculus. And we don't want to take 3 weeks to learn enough calculus to do it. So this is going to be one of the few times where I'm just going to give you a formula and ask you to trust me that that's the right formula. So for the volume of a sphere, the volume of a sphere is 4/3 times pi times the radius cubed. So let's say this sphere has a radius of 9 feet. This volume will be 4/3 times, we'll put 3.14 for pi, times 9 cubed. So 4/3 is 4 divided by 3, times 3.14 for pi, times 9 to the power of 3, so 9 cubed, 3,052.08. That was in feet, so this is going to be feet cubed. That's my volume. Surface area is 4 times pi times the radius squared. So we still have the radius of 9 feet. So our surface area is 4 times 3.14 for pi times 9 squared, which is going to give us 1,017.36. That's in feet, so this is in feet squared. Remember, this here was in feet cubed. What do you think? A lot of stuff to remember. So now remember, we do have a quiz that is due tonight. (11:59 p.m. tonight). And then there's homework for Monday. The quiz, remember, is on the stuff that we taught last Monday, which is your dimensions and stuff like that, rather than area and volume. The homework will be on the area and volume stuff. The homework does not include a lot on surface area. And I don't know why they chose to exclude surface area from this unit in the book. When we take our last unit test, that last unit test will have area, regular area, and it will have volume. Then surface area will be on there as extra credit questions. So that'll be a chance to earn extra credit. Okay, you guys have a great weekend.